Module 8, Lesson 2 covers the area of a triangle. The pacing guide claims this is going to be a 2-day to 3-day long lesson, but I just don't see it taking that long because there's only 13 resources total in it. The Biosphere 2 complex in Tucson, Arizona is used to research the Earth and its living systems. It provides scientists the opportunity to experiment with ecosystems in a realistic environment. Sections of the building, including the structure, the glass, and exterior, are composed entirely of equilateral triangles. Now we're going to select some buttons to see how each pair of the interlocking triangles create a parallelogram and how you can use the area of a parallelogram shaped figures to find the area of one section. So first off, you see the triangle that's right there, and then if we were to take and put two triangles together, you get a parallelogram. And we all know the area of the parallelogram is going to be base times height. So if we're only using half of that area, that leads to a pretty interesting questions about what we need to do with our formula. As we get started into actually learning how to do these, we get another definition. It says congruent figures are figures that are going to be the same size and the same shape. A diagonal on a parallelogram that separates it into two congruent triangles, since the congruent triangles have the same area, the area of the triangle is going to be 1/2 of the area of the parallelogram. Now let's watch a video to see what they're talking about here.
Find the area of a triangle. A parallelogram can be used to find the area of a triangle. Calculate the area of the parallelogram by multiplying the base times the height. It has a base of 8 units and a height of 12 units, so the area of the parallelogram is 96 square units. Use a straight edge to draw a diagonal line across the parallelogram to form two congruent triangles. Cut out the parallelogram. Cut along the dotted line to make two separate triangles. The area of one triangle is half the area of the parallelogram. So the area of the triangle is 96 divided by 2, or 48 square units. Try another one. This parallelogram has a base of 10 units and a height of 8 units. So the area is 80 square units. Use a straight edge to draw a diagonal line across the parallelogram to form two congruent triangles. Cut out the parallelogram. Cut along the dotted line to make two separate triangles. The area of one triangle is half the area of the parallelogram, so the area of the triangle is 80 divided by 2, or 40 square units.
Now the point of all that was to show you that the area of a triangle is going to be 1/2 the area of the parallelogram, or 1/2 the parallelogram's formula. The formula for the area of a triangle is derived from the formula for the area of a parallelogram. It uses the base and the height of the triangle. Now once again, these are vocabulary terms, and on your vocab quiz you're going to find that those vocab terms are a little bit different than the vocab terms for the height and the base of a parallelogram. So you need to make sure you understand those. The base of a triangle can be any one of its sides, doesn't matter, and then the height is going to be the perpendicular distance from the base to the opposite vertex. That's all there is to it. So if you were to pick this one over here as your base, then the height would be the distance from this line to that vertex. If you pick this as your base here, the height would be the distance from that line to that vertex. Easy math. Anybody can do this stuff. Now we're going to take and find out hopefully what the formula is. It says the area of a triangle is equal to 1/2 the product of its base and its height. And the formula they're going to give us is going to be area is equal to 1/2 times the base times the height, using a fraction right here, or area is equal to the base times height divided by 2. Now when I do it, I'm going to be doing this one right here because I find that's easier for y'all to work with. There is a third formula out there that we use as well, and that one would end up being area is equal to base times height divided by 2, using the vinculum. And this symbol right here, that is known as the vinculum. It divides things. You see that that really is no different than the formula that they gave you, base times height divided by 2. It means the same exact thing. And then of course their third formula, the one we used when I was in high school, 1/2 times base times height. 3 different approaches you can take, and which one you choose, well, that's going to depend on you and what you like the best, but it should also depend on how the problem is written. So let's dig in and work a problem. We're looking at example 1 here, where they give us a triangle, and that triangle you can see would have a base of 6 and a height of 4, but you could also argue that is a height of 4 and a base of 6. It really doesn't matter. From here we're going to take and plug in, not sure why my mouse isn't working, plug in a formula. Now the formula they're choosing is the one they made me use in high school, which is area is equal to 1/2 times the base times the height. That's not the one I'm going to use for y'all, but it works very well. Where A represents the area, B represents the base, and H represents the height. Now I should point out here that A represents the area, and that A is a capital A. We always capitalize area. Meanwhile, your base and your height are both going to be written as lowercase numbers. It's just what we do in math. I've heard no good reason why, but I always figure it as you got big picture thoughts and little thoughts. The base and the height, they're little insignificant things. The area, that's a goal we're reaching for, so we're going to capitalize it, and that's why it's capitalized and the others are not. No. Now it says in this triangle the sides are going to be, are they parallel or are they perpendicular? They're going to be perpendicular because it is a right angle. Remember, perpendicular lines meet at a right angle or 90 degrees. And we're going to use a base of 6 and a height of 4 to solve it. So we're going to check that part checked. From here we're going to move on to the next. Plugged in the formula they want to use. It says area is equal to 1/2 times the base times the height. From there they plugged in the base is going to be 6, the height is going to be 4, and now you actually have choices. You can find 1/2 of 6, you could find 1/2 of 4, or you could multiply 6 times 4, whatever you wanted to do. They chose to do it all at one time. I don't really like that. Giving you 1/2 of 6, which would be 3. 3 times 4, that is going to give you 12, and that means that the area of that triangle is of course going to be 12 centimeters squared. Now if it was me working this problem, I would have used a different formula. I would have used area is equal to base times height divided by 2. From there I would have said area is equal to the base is 6, the height is 4 divided by 2. And then I would say from there, area is equal to, well, 6 times 4, that's going to become 24 divided by 2, which is going to equal to 12. In the end, I get the same exact answer they did. I really like my way better, but either way is perfectly legitimate. Now it's going to be your turn to stop the video, work extra example number 1, so that you can find out if you know how to find the area of that right triangle. The first thing I do when I work a problem like this is write down my formula. The formula I'm going to choose to use is going to be the area is equal to base times height divided by 2. In this one I've got my base is going to be the 4, so that's going to be 4 times the height is going to be 3. Remember, your base and height meet at right angles. all divided by 2. Therefore, area is going to equal to 4 times 3. That's going to give me 12 divided by 2, which means the area is going to equal to 6, which in this case is going to be 6 inches squared. Jump back over here, type in my 6 inches squared, hit check, and we're good. For example number 2, we're taking a look at an old school pup tent, and it says the front of the camping tent has dimensions shown. So you can see you've got a base of 5 1/5 and a height of 3 1/2. How much material was used to make the front of the tent? In other words, what's the area of the front of that tent going to be? So to find that out, first thing we need to do is let everything load up here. The height was going to be 3 1/2, so we're going to type in our 3 fraction 1/2. And then our base is going to be, what was that, 5 1/5. So we're going to type in our 5 fraction 1/5. Whoops, missed that over there. 5. And we're going to hit accept. And those checked out good. So now we have identified the base and the height for the area, finding the area of our tent face. Now from there, we're going to take and plug it in. So once again, we have the base is indicated as 5 and what was that one? Let me look again. 5 1/5. So we're going to take and plug in a 5 fraction bar 1/5 here. And then we're also going to have a 9 3/2 right there. So give me a 9 1/2 right there. So we're going to have 9 fraction 1/2. That's going to be that. No, it wasn't. It was 3 fraction 1/2. I'm looking at too many things. So that part's going to be done. And then when they multiply all that out, they go boom and have some strange answer of 9 1/10 without doing any justificating work. That's not going to work for me. You've got to give me some justification. So let's work on some justification to go with that problem. I'm going to take and plug in what we know right here. Next thing we have to do, of course, is convert those mixed numbers to improper fractions. That means area is going to equal to 1/2 times 5 times 5 is 25 plus 1 is 26 over 5 times 3 times 2 is 6 plus 1 is 7 over 2. The next thing we're going to do is look for things we can simplify. So for example, in this problem, I can take and say that 2 goes into 2 once and 2 goes into 26 13 times. I don't see anything else that will simplify there, so I'm going to multiply. Area is equal to 1 times 13 is 13. 13 times 7, that's going to become a 91. 1 times 5 is 5. 5 times 2 is going to be 10. And that's going to equal to 9 1/10, which incidentally is the same thing that they put down right there for their final answer. So the area of the material that would be required to make the front of that tent is going to be 9 1/10, and cubic feet, I believe, is what that one unit was, or squared feet. And now it's going to be your turn to do this problem on your own. Find out what the area of the triangular front of this triangular prism is going to be. So starting off my problem, I'm going to take and write my formula. Of course, the formula is going to equal to area is equal to base times height divided by 2. You can use any of the 3 formats for the formula you wanted. Where now I have area is equal to the base, that's this distance here, which is the same as this distance here. So that's going to become 10.5 times the height. That's going to be this distance here, which is going to be 8.4 divided by 2. But this time I'm going to do something a little different. I'm going to do a little simplifying before I multiply, because I really hate multiplying decimals by hand, and I'm dividing decimals by hand. It'd be easier to knock some stuff out ahead of time. So what I'm going to say is that 2 goes into 2 one times, and 2 goes into 8.4 4.2 times. From there, I'm going to take and do my multiplying, and I'm going to have my 10.5 times my 4.2. The multiplied out, 2 times 5 is 10, And that's going to be a 1, and that's going to be a 2, that's going to be a 20, and a 2, and a 4. Add those up, 0, 1, 4, 4. Bounce, 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 bounce. My final answer is going to be 44.1, 1 over 10. Over 1, also known as just being an area of 44.1. But jump back over here, type in our 44.1 centimeters squared. The answer checks. That's going to be it for part 1 of this lesson. Come back to watch part 2 to finish up our study of finding the area of triangles.